compare functions. And so to start off, we can draw our pictures of f of x and g of x, and maybe let them help us to fill in our boxes down here. And the first one, f of x equals x squared, we've been practicing that for the last couple days, has the points 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. It's our quadratic function. And it looks like that. We also have our g of x function, which is the cubic function. And again, we've been practicing. And 0, 0, 1 cubed is 1, 2 cubed is 8. And if we think about it, it's symmetric with respect to the origin, which means that we also have the point negative 1, 1 and negative 2, 8. There's our two functions. And what we're going to do is we're going to compare them today. And we can use algebra to compare, or we can use the graphs to compare also. But our first one is f of 0. Well, f of 0, if we put 0 back into the function, what's going to happen is we're going to get 0 squared. Putting that 0 back into the f function. Comparing that to g of 0, if we put 0 back into our g function, we get 0 cubed. But 0 squared equals 0, and 0 cubed equals 0. So if we compare these two functions, they're equal at f of 0. And the other thing that we could do is we could look at the graph. When this is f of x, so when x is 0, even though my picture's a little bit off, y is 0. Over here in the g of 0, that gives us our y value, that's also 0. But I think it might be a little bit clearer if we use the algebra. So if we go to our next function here in part B, f of 1. Well, 1 squared, we're going to compare to g of 1, which is 1 cubed. But if we square 1 squared, we get 1. Or if we if we cube 1, we still get 1. And again, what happens is, when we compare them, they're still equal. But as we can clearly see here, these graphs are not always going to be equal. So if we look at part C, f of 2, well, this is going to be 2 squared. When we figure out g of 2, putting 2 back into our function, wherever we see x, we have 2 cubed, and 2 cubed is 8. 2 times 2 times 2. 2 squared is 4. 2 times 2. On this one, there actually is a difference, and what happens is that 4 is less than 8. So f of 2 is less than g of 2 at this function, on this function. So you kind of get the idea of what we're doing here. Be careful on the next one, f of negative 2. Well, that means that we have negative 2 squared. And we're going to compare that to g of negative 2, which is negative 2 cubed. If we figure out those values, negative 2 squared means negative 2 times negative 2, which is positive 4. And negative 2 cubed is negative 2 times negative 2 times negative 2 is negative 8. So we have a positive 4 and a negative 8. That means that when we evaluate our functions at negative 2, we're going to have our g function is going to be smaller than our f function. If you go back and look at this just for a second, back at the pictures, because I don't want to not refer to them. -2, there's the 4. -2, here's the -8. So maybe you can look at the graph as well. If we look at f of 100, well, then we're going to be looking at 100 squared. We're going to compare that to 100 cubed. And if you need to, you can type that in your calculator, but 100 squared is 10,000. 100 cubed is 1,000,000. And 1,000,000 is definitely bigger than 10,000. So f of 100 is going to be smaller than g of 100. And lastly here, before we answer a couple of questions about our functions here, f of -100, well, -100 squared, we're going to compare that to -100 cubed. And -100 squared is 10,000. -100 times -100 is positive 10,000. -100 cubed is negative times negative times negative. It's -1,000,000. I've got the right zeros, and I do. So, once again, a negative number is smaller than a positive number. So our g of -100 is smaller than our f of -100. But what I'm trying to lead up to here is what happens to these functions here. And so it says, which of these functions is greater as x approaches infinity? So first of all, just to give you that notation here, x arrow, the arrow means approaches infinity. What I did on my paper is I wrote the answer right underneath it. And before, or in order to answer it, what I'm going to do is I'm going to type both of these functions into the calculator. I don't really need to look at the picture so much. I want to look at the table. But so what we're going to do, it says which of these functions is greater as x approaches infinity. So I kept it in the same format here. If we compare this, when we go over here to type it in, go to y equals, and we type in x squared, and y equals x cubed. And what we're going to look at is we're going to look at the table here, and you're going to see some familiar information. I'm going to start back at 0 here, because the first one we did, we put in 0 for both the functions, and we ended up with 0. We got 0 out. We put 1 into the functions, we get 1 out. We put 2 in the functions, we got a 4 and an 8. But what's happening here as I look here, starting at 0, is as x gets bigger, as x goes to infinity there, the numbers as the x values are getting bigger, what's happening to the y values? And that's what we're comparing. We're comparing these y values. So as we go through, like we started, we ended up with them being equal. But then when we got to our third function, we saw that as x is getting bigger, our cubic function is getting bigger faster. The red numbers are larger than the blue numbers. So it says, which of these functions is greater as x approaches infinity? Well, g of x is greater than f of x. But we want to look at that same picture again as well. Which of them is greater as x approaches negative infinity? So we're getting to be super duper duper big. Now we're going to go very, very, very small. X approaches negative infinity. Still looking back here at our picture. So I do want to start with 0, but it's going to be at the bottom of my screen now. So when we look at our functions here, so as x starts to get smaller, we started here at 0 and we can see up to -10 on our screen. What we're going to do is we're going to compare the blue part of the table to the red part of the table. And what we see in this case is that all of the blue numbers are positive numbers, and all of the red numbers, except for the 0, are negative numbers. So as we start to get smaller, as we start to go towards negative infinity, what we see is that our cubic function is the one that's getting smaller, because we've got positive values in the blue, negative values in the red. So as we go towards negative infinity, and we compare our functions, our g of x, I'll make my box here, our g of x is the smaller value. So as I flip over here to the next page, I have one repeat, sorry about that, but letter H here, if I scoot that up there, we can't even see it now. State the interval over which f of x is increasing, and state the interval over which g of x is increasing. So let's start with f of x. And just to refresh your memory from Algebra 2, when something is increasing, we're describing it with x values. So when we go back and look at our graph here for a minute, and even though I didn't do the best job drawing it, when I started we're left to right, and we went down and down and down and down, and then we went up, 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 up. The question says, where is it increasing? Well, where it's increasing is, it starts here, and then we go up. So it starts at 0, and forever on, as we go towards positive infinity, our graph is going to get bigger and bigger and bigger and bigger. It's going to increase. So where is our interval of f of x increasing? It's increasing from 0 to infinity. We don't include 0 in that point. So if we look at our g of x function, and without flipping it back here for a second, our picture looks like that roughly. Once again, we read the graph from left to right. And if you saw me draw it, I started down here at the bottom and I went up to the top. So what would happen is I would start and it would go up, 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 up. And because we read the graph left to right, I'm always going up. So where is the graph of the cubic function increasing? Well, it's always increasing, because you read it from left to right. So from wherever you start from, and then when you draw it, you're going to continue to go up. It's always increasing. Now, where is f of x decreasing? If we go back here on the front, again, starting from the left, when we draw our picture, we start and we go down, 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 down. We get to the lowest point, our turning point down here, and then we go up, 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 up. So where we're decreasing now, we use the x values to describe it. It's going to be from negative infinity to 0, we're decreasing. It's a parentheses, not included. So to finish with this problem here, which function has a minimum value? Well, again, I always, when we're looking at domain and range, I like to say, do we have a high point, do we have a low point? So which one of these has a low point? It's our f of x function. We have a low point. We don't have a low point on our cubic function. So f of x has the low point. And then finally here, given negative f of x and g of x, compare the functions. So let's go back to our calculator here. And back in the y equals, if you're not familiar, I'm going to use second and the delete button, which gets us to insert. And that allows me to put a negative in front of the function. And what we want to do one last time is we want to compare our functions now when x squared has a negative in front of it. Negative f of x. So we're going to go back to our table. And I'm going to start at 0. Because the first question is compare the functions as x approaches infinity. So this time we've got our function negative f of x compared to g of x. So we come over here, and what we've got then, when we look at our blue values, those are all negatives now, and our red values are all positive. So when we compare these functions as x approaches infinity, our blue graph now, our f of x function, which was negated, is going to be the smaller value. So it'll be interesting to see what happens as x approaches negative infinity. So if we go and scroll back here on our calculator, when we look as x approaches negative infinity, we have -4 and -8. -8 smaller. -27 smaller than -9. -64 is smaller than -16. -125 is smaller than -125. Our g of x function is now smaller as we approach the smaller numbers, as we get smaller and smaller, go towards negative infinity. So as x approaches negative infinity, it's our negative f of x function and our g of x function. The g of x is going to be smaller.